For my case study, I decided to study about the lung capacity to compare it at rest versus exercise. For the introduction, you have the spirometer, and it's the most frequent pulmonary test for breathing, and it determines how much air that you inhale and exhale and how effortlessly and quickly you can blast air from the lungs. So over here you have your regular spirometer. It's probably the cheapest one that you can find on the internet. But I ended up going ahead and getting a more expensive one, a digital one, and it contained the FE1 value, which is the amount of air exhaled during the first second of the first exhalation, and the PEF, the speed of the exhale at maximum force. The spirometer will be having the participants being in an upright position, and the mouthpiece will be attached to the spirometer equipment. The participant will be urged to close their lips securely around the mouthpiece and take a huge, deep inhale and before blowing out forcefully and as quickly as can. This maximum effort is critical, and testing will be done at least multiple times to achieve the best findings. So over here I decided to show this diagram on how to use the digital ones. I've used the digital one for the experiment. In step one, you'll be standing up and you have the peak flow meter between both hands. Step two, you take a deep breath and blow into the mouthpiece as hard and as long as you can. Step three is you exhale, bend forward to push all the air from your lungs. The values of the respiratory after 5 days were collected during the pre and post exercise phases. During the trial, participants were not allowed to modify their activities, so they weren't able to change the exercise that they were doing. So we're using running on the treadmill for the exercise, and the exercise duration remained the same. And will be the controlled variable. The independent variable was the time. So the time when before and after exercise, and the dependent will be the lung capacity because it'll be changing throughout, and we'll see the correlation between the exercised lung capacity versus the resting. Age, height, and gender are used as normal values, and it also plays a part on what is a normal lung capacity for each person, because we saw that in males that they have bigger organs and bigger lungs, so they have bigger values in the lung capacity. And if you don't see that you fall into the right category for your lung capacity, there might be a condition that you have. So PEF and FEV1 are good markers of good respiratory function that decrease because of your unhealthy lifestyle. Long-term activity will increase the lung capacity, and the primary goal was to see that the effect of the exercise on the lung function, the two values that we're measuring with the digital. So we saw that there was a decrease in the FEV1 and the PEF values after exercise in all 5 days in data recording. So over here we would have the charts, and this chart on the left is your PEF values, and you see that each time after exercise you see that decrease in the value, and as well as the FEV1 values, they were a decrease in each of the days after post workout. So statistically saying, I wasn't able to compile my statistics. So there's I cannot say there was a significantly difference. But I did see that the PV and the FEV, according to visual analysis, we saw that there was a difference in correlation between the two, but since I do not have my p-value, I would have to dismiss my hypothesis. And this was an interesting case study